The next thing that we want to do is find the equation of the tangent line to f of x when x is the solution that we found in part 3. Remember that in part 3 we found x equals 4 was our solution. Once we've done this, we will then draw the tangent line on the graph that we've made and make sure that it goes to the x-axis, and that will again become this new value that we use in our iterative process. So to find the equation of the tangent line, we again first need to find the slope at our value x equals 4. Recall that we found that the equation for the slope, or the derivative of our function, was 2x, so we need to take 2 times 4, and that gives us a slope value of 8. We also need the point that corresponds to this. That means at f of 4. Remember, our original function was to take x and square it and subtract 7. That gives us 16 minus 7, which is 9. So we end up then getting the coordinate 4, 9. We've got a point, we've got a slope. We can plug into the point-slope form. So again, we're going to take y minus y1 equals m times x minus x1. This gives us y minus 9 equals 8 times x minus 4, or y minus 9 equals 8x minus 32. And then that tells us that y is equal to 8x, and then adding 9 to both sides, we end up getting minus 23. So that's the equation for our tangent line. Now we know that the eventual goal of this is going to be to solve this equation that we found for the tangent line when y is equal to 0. So before I travel to the next screen, I'm going to do that for you. We're going to end up getting then 0 is equal to 8x minus 23. Adding 23 to both sides, we get 23 is equal to 8x. And then dividing both sides by 8, we end up getting a solution of 2.875. So when I draw the equation for the tangent line, we're going to end up going through the x-axis at x equals 2.875, and this will be the next value in our iterative process. So going back to our graph, we can again plot this tangent line. We know it's going to have an x-intercept at 2.875, which is about here. And it will have a slope of 8, so it's going to have a very high slope. It looks something like this. We won't even be able to see the y-intercept, it's off the page. But notice what's happening here is that our points are getting closer and closer to that true 0 that we are looking to find. And that's what Newton's method is going to do for us.